First thing, fraction. From now on in, integral, fraction. C fraction, think log. C fraction, think log. When I say C fraction, think log, you turn around, you look at your denominator. What's the derivative of x plus 1? 1. Who's on top? 1. We're happy. It's a log. Bang, bang. Thank you very much. As simple as that. See a fraction, look at the denominator. If I derive it and I get what's on top, the answer is log bottom. Log bottom. So that's a straight example.
That's it.
That's it. Straight away I recognise that, yeah. Right? But obviously life gets tougher as we go on. C fraction, think log. Go to the denominator. What's the denominator? X squared plus 4. What's the derivative of x squared plus 4? 2x. Not happy, but happy. Not ecstatic. Here, jumping for joy. Here, big concerned, but no big deal. Right? What can I do?
Pull out the x3x. The integral.
Yeah, what's wrong with what I'm getting and what I've got? I'm out by a factor. How much am I out by? We're going to be talking about a multiple. Okay? You can't take away or add. So, this is a bit of a cheat's way. But don't do this. Right? This is in your head, but don't write this. Because it's bad math. But it gets you there. As soon as I see a denominator, fraction, I'm thinking it could be a log. I write the thing on top outside. And I leave the bottom there. Yeah? What's the derivative of x squared plus 4? 2x. So I turn around and I write that on top. I'd be ecstatic if that's the sum you gave me. Because that's a good log. It works. So then I adjust it on the outside. Right? So pull out the top, tell me what you want to be happy, and adjust it on the outside. The x's cancel. I'm left with 3 on 2. This, I was jumping up and down for joy because it's a perfect log. Log x squared plus 4. So 3 on 2 is the adjustment factor. And sometimes people can't see that clearly. Right? Sometimes you can't see that clearly. So that's the technique you take. But don't show that. It's on the side of the paper. It's not formal work. Huh? Yeah, but it's bad working out. Because you're not allowed to divide by things with x. You can't just
show that it's good outside.
It depends on.
It's working out.
Depends on the example. Depends on the example. It's not great notation. So what we do, I do it in my head. And there's another way they do it formally, like in special with U and stuff.
Why don't you do U?
Because we don't do U substitution.
It's simple though.
Yeah, I know, but we don't do it. Alright? Looking at C. Fraction. See a fraction. Look at the bottom. What is the derivative of 2x squared plus 2x plus 5? 4x plus 2. What have I got on top? 2x plus 1. You're giving me 4x plus 2. I only want 2x plus 1. I only want half of what you're giving me. Can everyone see that ratio there? The derivative of this is 4x plus 2. That is twice as big as that. So my answer must be half of what I want. Right? Compare the derivative you get to what you want. How do you turn their derivative into what you want? That's the adjustment factor. I only want half. You're coming and saying, here's 4x plus 2. I don't want it. I only want 2x plus 1. I only want half of what you got. Here, I needed more than you were prepared to give me. You were prepared to give me 2x. I needed 3x. I needed 1.5 times as much. Here, it was a perfect relationship. People have, that's how logs can change. It's just really the adjustment factor. And if you're not sure about working the adjustment factor out, do this little method. Say, look, I think he's telling me it's a log. I'm not sure. Put what you want on top and adjust it on the outside. And things will cancel. And you'll get there. Things will cancel and you'll get there. Yeah?
Whatever the denominator, you put one down.
Sorry? Yeah, what the adjustment factor is always in front of the ln.
Oh, okay.
Yep. Okay. D. Last one. Oh, yeah, last one. No, one more after this. One more. One more because I'm just thinking of something that we... Have a look at D. I see a fraction. I look at the denominator. The derivative of x plus 3. 1. 1. I want 1, you're giving me x. What the hell? What do I do?
Times by x.
Bang. Dead. I should have get my... You know, I've got my Nerf gun here. I might get it.
I get it.
Finish it off.
I got it right.
They locked the door on. Do I get it or not? They locked the door on. We can't. Never, ever, ever can you multiply or divide by x. Never. So we can't change it by that factor. Go back. Term 1. Think. Connect the dots. We're drawing graphs. Can you tell me the asymptotes off that graph?
Negative 3.
X equals negative 3. Good. And the other one? Y equals?
0. 1.
I'm going to get that gun.
Oh, get it, sir.
Obviously it doesn't. The impact.
What's the Y asymptote?
Brother, give me a warning when it comes. Hey, give me a warning. Give me a warning.
Next answer.
Y equals 1.
What do we do? Oh, I was meant to do buzzer. Why? Why? What do we do with the graphs? What did we do with the graphs? X over. Top and bottom are equal in power. Or top is bigger than bottom. What do we do? What do we do? What's the first thing we do? If the top and bottom are equal functions. Long division. Thank you. So, divide x plus 3 into x. Right? These techniques come back. No, it's not, and boys, that's what we have to learn. We can't just go, oh, I'm in graphing, my brain thinks graphing, and then in calculus, my brain thinks something else. The whole bloody thing's put together by the end. It's got to all connect. As I can't draw graphs when they look like that, I can't find antiderivatives either. In methods and in speech. You don't want the top and bottom to have the same basic power. So if I divide that into that, it goes once. Yeah? Multiply back becomes x plus 3. Do the division, that becomes negative 3. So that is the same as saying 1 minus 3 over x plus 3 dx. So I've reorganised it. Yeah? The antiderivative of 1 is x. Hey, that's now log. Because the derivative of the bottom is 1. I've got 3. That's okay. I'm never phased by number differences. I'm only phased by letter differences. Minus 3 log x plus 3.
So I don't understand the rule. Say 1 over x something.
Yes.
Don't interpret one. So we pull out the number, whatever number's in them.
Yes, but what you're okay. You're okay. So you're saying you do this and you put an X out the front, yeah? Okay. What's the derivative of this? So you write 1 here, and then I write 1 here. If they don't cancel, you're dead. You're not allowed to do it.
Why? Oh,
Here, they cancelled. It left me a number. The answer only is allowed to be a number in front of the log.
So you taught us that long division this year, yeah?
So what?
We've done that before this year, that long dividing.
Yeah, yeah.
Because that's what this year.
Who said we haven't?
Oh, GG, right.
I better take that off.